Hello everyone, so welcome back to lecture number 2 on engineering mathematics, and the topic is vector calculus, right? So this season is going to be very helpful for GATE 2022 or any examination you are targeting as far as the engineering is concerned. And you already might have seen beautiful applications of these concepts, okay? How to compute arc length of a curve. Any curve is given, if there is a arc, how to compute that, right? So already we have seen the concept related to vector calculus in our lecture number 1. That was vector function. What is the definition of vector function already? Okay, let me recap here. Okay, so this was the page. Here you can see the vector calculus. Okay, we started with vector function of one variable, function that maps a real number to a vector. Okay, and you have already seen various examples here. I showed you the vector function in 3D plane, and this was the vector function in 2D plane, right? And here the vector here the space variable is the function of time, okay, which we have parameterized, okay, that x was, if what I take x equal to r sine theta or r sine t, you can take, right? And here the variable is time, okay, and this was the nice example to construct vector function, okay, and this was the nice way of geometrically we can visualize vector functions, okay. Already we have seen and also claim that if you're talking about if your discussion is on vector setting, so you need to take care of not only plot but as well as the orientation. As you change the time t, okay, the in the increasing direction of time t, you have to take the orientation, right? So already we have seen ellipse and circle and helix here, and how we apply the limit continuity on the vector functions, okay. Component wise you have to keep in mind. So these things I have discussed, and continuity, and we also discussed about tangent, right? The differentiability, right? The important concept of differentiability. So r of t is said to be differentiable. Again, you have to differentiate component wise, okay. This was the concept, and this was the geometrical interpretation, right? And I also told that I'm gonna talk about the arc length of a curve in differentiation. So now we will talk about the arc length of a curve. This is very important. In fact, in if you go back and check your ESE paper, prelim paper, right, you will find some questions from arc length of a curve or in the gate examination now. So after watching these lectures, you can try PYQ, previous year questions, and you would definitely be able to solve questions confidently, है ना? क्योंकि you don't have to mug up any formula, because I'm trying to cover basics from the scratch, okay? So let's begin our discussion on arc length of a curve. So I'm just going to consider the defined position vector, the vector function here, okay. My vector function is given like, let vector function is r of t, okay. Why I'm calling it vector function of one variable? Because you can see only the variable is time here, right? And your space space variable is also a function of time. So here x of t sitting along I cap, and y of t sitting along j cap, and z of t sitting along k cap, right? This is your vector function, already you have seen. And if we recall from our integral calculus, the parametric equation of a curve, okay, so already I have told you that how to parameterize, okay. So yeah, when you will go in future, when we will talk about line integral, and if anything is given in the form of time, okay, so you can parameterize, okay, that is parametric equation will be given, and you can plug in place of x, you can plug x of t, okay. In place of x you can plug x of t, okay. This is a parametric equation of a curve, okay. By, in place of y you can plug y of t, okay. Like x equal to will be given as sine of t, right? So you can place, suppose any vector is given x I cap by j cap, any and j z k cap, right? In place of x you can plug x of t by equal and z equal to, you can put z of t, right? So this is the parametric equation, okay. You must know how to parameterize and when to parameterize, okay. So parameterization gives you easy way of solving questions, right? So ये concept बहुत बार आ चुका है गेट में. If you go back and check previous year question paper, so parameterization application is a lot. Okay, so please go back and check. तो अब आप कंफ्यूज नहीं होंगे. यू हैव टू सॉल्व क्वेश्चंस कॉन्फिडेंटली. Parameterization is very important sometimes, okay, to tackle any integral. Okay, inside the integrand you can using this parameterization inside the integral you can change the variable with respect to one variable only, right? Suppose there are x y z multi-variable, right? Multi-variable function, so you can change with one variable and compute the integral. Okay, so this is the parametric equation of the curve. Parametric equation of the curve. Okay, you have to keep in mind. So next time when you come across parametric equation, don't be worried and don't get scared. Okay, so how to compute length of a arc length of a curve? So length of a curve is computed like this. So you have to take the differentiate. You have to take the derivative of each component. Okay, component wise you have to differentiate first. Okay, so let's differentiate x of t. Okay, and then take the magnitude here and square of this. Okay, and then you have to differentiate by of t. Okay, that parametric equation, and then square. Okay, square of this magnitude, and then z of t, derivative of z of t, and take the magnitude and square. Okay, and then take the under root here. Okay, you have to take the under root, and then you have to integrate, okay, between a and b. Okay, this integration will run from and this will be dt, right? So this is how we compute the arc length of a curve, right? This is how we compute arc length of a curve. So the vector function will be given, okay, and the parametric equation will be given if in the question. So you can directly find the arc length of a curve by using this formula, right? So this is don't take it like a formula, this is a concept you can take, so you will always remember. So here the application of differentiability is there. If any component is not differentiable, then problem will be. Make sure that in the question, if you have to check as well all the components are differentiable or not, right? So, and if I talk about this integrand part here, right? So let's talk about this. What is this? Let's note that. Okay, note that this is basically, suppose r of t is given as x of t, right? I cap, by of t, j cap, and z of t, k cap, right? So what is this? You have to differentiate first, right? So differentiation would be happening component wise, x dash t, okay, by dash z, okay, and derivative of zt, right, k cap. And can you take the magnitude of this guy? So r dash of t, this is how we take the magnitude. Suppose a vector plus jb vector is given, so we can take the magnitude equal to a square plus b square, right? This is how we compute the magnitude, right? So here you can take the under root and take the magnitude. Okay, so this is going to be your okay, so you can take the magnitude here and write x of t, okay, square plus and so on and so forth, right? And this is going to be by dash of t square and plus this is z dash of t. In the vector setting, this is how we compute. So what is this basically, what we call this? Okay, इसको हम लोग क्या बोलते हैं? Okay, you have to keep in mind this is basically the length of the tangent vector. What is this? This is basically the length of a tangent vector, right? So if somebody will ask you, can you find the length of a tangent vector, right? So you have to read the question carefully what they are asking. Okay, if in the question it is mentioned that calculate length of a tangent vector, so you have to differentiate component wise and then take the magnitude, right? So this is going to be your length of a tangent vector. Already I've told you this will be denoted as r dash of t, and this is your length of vector, right? And if you're going to okay, if you're going to here you can write again and again if you will write, so these things will be imprinted in your mind, right? So don't avoid writing things. Okay, this is the length of a tangent vector. And if you look that integrand carefully, in case of arc length of a curve, this integrand, right, this integrand, okay, which is inside the integral, right? So this will be what, this is basically the length of the tangent okay, curve, right? So we can write that length of a length in terms of position vector. If you calculate, okay, length in terms of position vector, okay, position vector, here the position vector, right, r dash of t, okay, length with respect to r dash, not r dash of t, this is position vector r of t, right? So how you're going to compute length in terms of position vector? This is going to be from a to b, and you have to write the length of tangent curve, right? That's r dash of t, okay, that is going to be dt, right? So this formula you can use, okay, to compute arc length of a curve, right? So this is how we have to compute. Already we have seen how to compute distance between 2 points, okay, and magnitude if a vector is given, right? So these things you can do, right? So guys, with this I would like to end session here. So in the next session we are going to talk about gradient of scalar function, right? Because after all our objective is to convert all the scalar function into vector function. So if you are going to operate this gradient operator on scalar function, so that will give you the vector function, right? So this operation will give you guys, you will go from scalar function, okay, to vector function, right? If you will apply now vector function, okay, so we'll see the geometrical interpretation and physical significance of gradient as well, and this will be very helpful for your interview preparation, your when you will go for ISRO examination or ISRO interview. They might ask question, you know, in old days, in I mean, not in old days, we can say in 2013 2014, when I was preparing for the examination, so many of my colleagues, they used to ask to me that Dheeraj, can you explain what is the physical significance of curl, divergence, and gradient? But those days, my mind was not that amazing, right? We were not thinking in this kind of a direction, right? So, guys, physical significance and geometrical understanding is very essential in today's world. Okay, if you want to understand uh, technology in future, and if you want to go for data science, machine learning, artificial intelligence, so these things are very important, the calculus, the linear algebra, okay, and geometrically how you interpret it, okay, interpret, right? So in the next session we are going to talk about gradient of a scalar function. We will try to keep the session as in terms of duration as you know, okay, so बहुत ही कम duration का हम लोगों को बनाना है, so that everyone should watch and do not lose the sight of understanding, right? So thank you so much. Please learn from this concept. We'll meet in the next session, and keep sharing this session among everyone, among your juniors in your university, schools, college, wherever you are studying, right? And learn the real concept, right? So we'll talk about scalar function, then we will apply some Nebula operator or del operator, right? And then we'll get vector function. Thank you.